Welcome back to your learning journey. Now in this video, let's talk about the Bayes theorem. Now when we talk about this Bayes theorem, it's one of the most popular machine learning concept, and this Bayes theorem helps us to calculate the probability of occurring one event with the uncertain knowledge while other one event has already occurred. That means here I'm trying to predict the chances of occurrence of one event by having a knowledge of the other event. Which means in this scenario, we'll be making use of the concept of conditional probability. Now from the definition of probability theory, when we talk about the conditional probability, it is given by the probability of occurrence of an event A given event B has already occurred is actually given by probability of A and B occurring together divided by probability of B. So this is actually known as the conditional probability. Now in this scenario of this conditional probability, what I'm trying to find is, okay, so if I have two events, that is A and B, and let us assume that there is a chance that both the events can occur together. In such scenario, if I want to find the probability of occurrence of unknown event A given unknown event B is given by chances of occurring together, probability of A and B occurring together divided by probability of B. Now this is the formula for conditional probability. Now from this formula of conditional probability, we can actually derive the Bayes theorem. So let us see how we can actually do that. Now when I talk about the Bayes theorem, so here in order for you to understand this Bayes theorem, let me just write down the formula again. Probability of occurrence of event A given event B has already occurred is given by probability of A and B occurring together divided by probability of B. Now let us say that, okay, if I have to find a probability of occurrence of event B given event A has already occurred. In such scenario, then the formula will become probability of B given A is equal to probability of A and B occurring together, because B intersection A and A intersection A would mean the same thing. Hence I'm saying that probability of A intersection B divided by, this time it is probability of A. So I'll call this as an equation number 2. Now what I'm going to do is I'm going to transfer this denominator to the left hand side. So my equation 2 is going to become something like this. So probability of A intersection B is equal to probability of B given A multiplied with probability of A. Now let us assume that if I call this as A, now if I substitute 3 in equation 1, then this would actually become probability of A given B is equal to probability of B given A multiplied with probability of A divided by probability of B. So this formula that you see right now, this is the formula that we call it as a Bayes theorem. Now as you can clearly see, using this formula, I can find the chances of an occurrence of a particular event given the knowledge of the other event. That is this term over here. So with this scenario, okay, with this formula, so I'll be able to calculate the probability. Now this Bayes theorem is one of the core concepts when it comes to the Bayes algorithm that we have got in scikit-learn. Here, this Bayes algorithm is generally used when we are dealing with tasks like the text classification and the common classification problem. That is where we observe the usage of Bayes algorithm a lot. And here in this, probability of A given B is equal to probability of B given A multiplied with probability of A divided by probability of B. Let us define some terms. So here, this time, the left hand side term, that is probability of A given B, we call this as a I'm going to call it as a posterior, which is what we are required to calculate. Now this is actually defined as the updated probability after considering the evidence. And probability of B given A, this time we generally call it as a likelihood. This is my likelihood. It is the it is the probability of my evidence if my hypothesis is actually true. And probability of A that I have got right here, this is called as prior probability. Here the probability of hypothesis before considering the evidence, and here probability of B is actually called as marginal probability. In this scenario, this is defined as the probability of evidence under any consideration. So in general, I can say that naive Bayes algorithm or this Bayes theorem is generally referred as posterior is equal to likelihood into prior divided by evidence. So this is how we will define the Bayes theorem. Alright, so this was about the Bayes theorem. And if I want to expand a little bit about its usage in machine learning, let us say that I've got a data set. Okay, let us say that I've got a data set, and in my data set I've got multiple columns, and I'll call some features as x1, x2, x3, x4 and x5. There are 5 features, and I've got a single target variable. Now when we talk about machine learning, I'll be interested in finding the pattern between my inputs and the target. Now let us say that I've got a trained model. Now the expectation is, given these features, okay, given ththese features x1, x2, x3, x4, x5, I want to generate the prediction as what will be the output class. So when we are dealing with the new data set, at that time, given these features, I want to get the target. Now this will be the prediction phase. Now, if I want to generate the prediction, I'll explain this in terms of the probability. So I'm saying that predict the target given the features. This is what I want to do. So if I want to predict the target given the features of my data set, I can make use of this Bayes theorem, and I can say that what is the probability of having a feature given a target. So this I would get it from my given data set. From the given data set, for each feature, what is the probability of that feature if my target is 0 or if my target is 1, assuming that I'm performing the task of binary classification. Let me repeat this as it's very tricky and very deep intuition behind this. So let us consider I'm dealing with the binary classification where I've got two classes, 0 and 1. Now what I'm trying to say is, what is the probability of occurring the feature x1 if my target I have known as 0? And this obviously you will apply the other terms over here. This will have the other terminology. So the core thing is here. If I want to predict the target given the features, I'll make use of the probability of occurring that specific feature, let's say x1, given the target as 0. In the same way, I'll go ahead and find the probability of feature x2 given the target is 1. Now whichever is the one that I'm getting the maximum probability, that's the one that I'm going to say that, hey, that will be the overall outcome. So that is the usage of Bayes theorem in the machine learning. So with the help of conditional probability, we'll be working with the data set in case of machine learning and trying to predict the target from the given features by making use of the conditional probability. Now, in order for this to work, there are some assumptions that we make. One thing is like each feature that we have got are independent of the other features. So that's one of the important assumptions that we would make whenever we are applying this Bayes theorem in case of machine learning. So we'll be covering more about this Bayes theorem and its intuition in our machine learning playlist. So do follow along with me on the machine learning playlist. So thank you so much guys for watching till the end. Do subscribe to our channel. Feel free to share it with your friends and family. And I look forward to seeing you next time.